Now, if you'll slide down to 2 special logs, I also want to cover this. Only properties today. When we get to class, we will work examples. So the first special kind of log is called the common log, and the common log always has a base of 10. Now, this is not the correct way to write the common log. What you see here that I've written, this is incorrect notation. The notation for a common log gets rid of the base. So we will write this just simply as log of x. The lack of a base tells me it's a base 10. Think about the difference between a cubed root and a square root. How do you know that this is a square root? Well, there's a lack of a 2 there. It's the same concept over here. The lack of a base tells you it's an automatic base 10. And then the natural log always has a base of e. We talked about the base of e back when we were doing compound interest. And so the base of the number e, again, we're not going to write it like this. We're going to write it as ln of x. ln is the same thing as log base e. ln is the same thing as log base e. Looking at some more properties here. Property number 1 is that log base a of 1 is equal to what? And for now, I'll put a question mark here, although I'm going to erase that in a minute so you don't have to write that in your notes. And if you'll think about changing this into an exponential statement, since we are more accustomed to writing exponentials. So think about what I just covered with you. If I start at base a and raise it to the power of a question mark and make it equal to 1, a raised to what power is equal to 1? This goes back to the 5-2 video where anything to the 0 power is equal to 1. So that question mark then is going to get replaced by 0. Anything to the 0 power is 1. That's the same thing as saying any log of 1 is equal to 0. Any log of 1 is equal to 0. Number 2 is the same concept. Again, I'm going to put a question mark in here for just a moment. And if I start at base a and hit the question mark, raise it to that power, and then that's going to equal a to the x, we would write that base a to the question mark is equal to a to the x power. Well, if bases are already equal to each other, then the powers also have to be equal since the 2 statements are equal. So if the bases are equal, then that means the missing question mark has to be an x. So then we have log base a of a to the x power is just equal to x. This goes back to the undo buttons. Think about the fact that a log and a power undo each other. Logs and exponentials undo each other. And then I'm going to do the exact same thing for number 3. Notice this is my power, and within my power I have a log. Now this is only going to occur when my 2 bases are equal to each other. Just like in number 2, my 2 bases were equal to each other. So anytime the 2 bases are equal to each other, one's a log, one's a power, they're going to undo each other, just leaving me with the number x. We'll work the examples in class. Now, if you will run all the way down in your notes to the section that says more properties of logs, more properties of logs. First of all, we're going to talk about the product rule. Do you remember that back in exponentials, the product rule was if you're multiplying like bases, you add your powers. Well, this one says the log of a product. So you'll notice here I have a log of a product, 2 things being multiplied together, is going to equal the sum. I've already got the addition sign over here for you. The sum of 2 logs. So my first log is log base a of x, and my second log is log base a of y. So that statement then, here I have a single log of a single product is the sum of 2 logs. Same thing for the quotient rule. Back in exponentials, we said that if you're dividing like bases, you will subtract your powers. And this one says that the log of a quotient, notice I have a log of a quotient. This is going to equal the difference, you see my minus sign is already set up over here, the difference of 2 logs, log base A of x minus log base A of y. Then you have the power rule. Remember the power rule back in exponentials said when you raise a power to a power, you multiply your powers. Well, what I'm going to do here is I'm going to take my power of y and I'm going to move it out front and use some multiplication. So there's my y times log base A of x. And then the last rule is a rule that you're really not going to run into very often, but if you are looking at a log and you see that it has a base you don't like a base of b, maybe it's a base of 3 or a base of 9 or a base of some number you don't like. Our 2 special logs are common logs and natural logs. Those are the bases we really like. So you might want to change it to one of those 2 bases. So if you had a log base some number you don't like, you can change it either to a common log or to a natural log. The way that you would do that is you're going to have log of x. Notice that I'm using the common log here. This is a base of 10. Log of x divided by log of b. Log base 10 of x divided by log base 10 of b, but we don't write the base 10. That's changing it to a common log. Or you could change it to a natural log where you have the natural log of x, log base e of x, divided by natural log of b or log base e of b. And that's going to be it for now. We will work the questions when we get back to this part in class.